Hi, this is Patrick Henry from QuestFusion with The Real Deal What Matters. I'm here today with Dr. Behnam Analui. And he is actually the co-founder and CEO of ABtum, which is a very cool company up in Orange County. I met Behnam because he's actually in the Evo Nexus incubator, which is a pro bono incubator here in Southern California with locations in downtown San Diego, UTC La Jolla area, as well as in Irvine. So welcome, Behnam. I'm glad you
Thank
were
you.
willing to do this.
Thank you for having me.
You bet. So why don't you tell me a little bit about your background, what you were doing before ABtum and that kind of stuff.
Sure. So let me say hello to your audience. I moved to US in 2000. Originally, I'm from Iran,
Okay.
and I came and went directly to graduate school to Caltech in Pasadena. And after I got my PhD, I moved to a startup company up here in North County, Luxtera.
Okay.
Very cool technology in silicon photonics. We were the only one who actually had the technology and brought in the first product into market. I was there until 2009, and around then was when, with one of my partners who was a professor at USC, we said, let's start a company together. And that's
Cool.
when I left Luxtera and went to USC, starting working on ABtum.
And that was a year or two ago?
That's actually in 2009. So it's been a
Wow.
few years that we
Okay.
have and I'm gonna tell you more about the detail of what the history is behind it. We spend a lot of time at USC working on the core technology that is now at ABtum.
Okay, great. So tell me a little bit, how did you come up with the idea for the ABtum product, and what motivated you to do that?
Uh, so the history is actually very interesting about that because we didn't know what product we want to do. We said we want to do a business and we want to do it based on a technology that matters. And so the first few months we were really looking at what are the hardest problems in the business, especially in the area where we are more familiar with. We started talking to people. We looked at different markets, and we
So
came.
you guys are both electrical engineers.
That's correct.
Okay,
That's
so you
correct.
were looking at kind of the most challenging electrical engineering problems
Absolutely.
in industry.
Yeah, just to give you a bit of an idea, we looked at medical devices. We were looking at pulmonary issues, for instance, measuring heart rate and breath rate, being able to detect humans using wireless technology. We were looking at timing. Timing is an important problem also,
Okay.
and creating very accurate timing solutions. And we were looking at radio,
Okay.
and that's where we picked the problem that is now, our products at ABtum.
Okay, cool. So when you talk about radio, in the engineering world, we talk about RF, radio frequency problems and challenges. I've been involved in that,
Mm-hmm.
the analog mixed signal world. Tell us a little bit about what is the product, that ABtum is doing, and what problem does it solve?
Absolutely. So we do radio frequency or RF filters, and filters are one of the most fundamental elements in almost any electronic system. In the radios and wireless communication, when devices want to talk to each other, they use signals, and you can imagine in the air there's so many different signals. Filter is the component that gives your radio the right signal, and basically clears out all the other noise that is in the air.
Okay, so for our non-technical audience, can you give like an analogy of, so it allows you to focus on just this part and ignore everything else, or what exactly does the filter
Absolutely.
do?
The best example I like to use is the FM radio.
Okay.
Everybody has an FM radio in their car.
Yeah.
And let's say you're a fan of KPBS.
Yeah.
It's the NPR channel in San Diego, which I really like and used to listen to.
Yeah.
You have to tune to your radio to, I think it's 89.5.
Okay.
And that's basically when you're tuning, what you're doing is you're setting the filter at the frequency of your KPBS.
Okay.
And every other channels are being filtered out.
Okay. So when you're, I typically listen to my iPod these days, but when I did used to listen to the radio, if you're like getting static or you can't really dial into the channel very well, is that the result of a poor filter, or what is
That
that?
for the most part. I mean, there are other. Obviously, radio is a complex element, but filter is the very first component that's basically takes out all the noise and static
Okay.
that is unwanted and undesired, and
Okay.
lets you actually tune into the right channel.
All right, cool. So you're doing basically high performance filters for every market, or what market are you focused on?
That's a great question. We, as I said, filters are applicable to a broad range of markets, and our technology at the core can be applied to a broad range of applications, any electronic system that needs to be connected. However, as a company, we have chosen to focus on mobile devices and cellular bands which mobile devices use because of its sheer big size, and having the most pressing need in terms of needing high performance filters.
Okay, and why? I mean, obviously that's an enormous market. We have a big company in town that's a big supplier in the market, Qualcomm.
Yeah.
They're having their challenges these days, but obviously it's still a huge market. What does your product do? What's your competitive advantage, your differentiation, the pain point that you're solving? Because obviously these mobile devices have filters in them today, right?
Mm-hmm. No, absolutely.
So
absolutely.
what do you do that's different and special?
So the biggest need that the mobile industry has today in terms of radios and in the front ends, as far as filters are concerned, is that the number of those filters are actually exploding. That comes from the fact that most of the smartphones today, they actually need to support many bands, many frequency bands, accessing different channels. Global connectivity is what all consumers want. More bandwidth is what all consumers want. And all of this results in needing a lot of filters inside devices. And what our solution does is, as opposed to putting us on a trajectory for needing to have up to 50 filters in the next few years, we can actually replace all those with a single tunable filter, which is very similar to the FM radio that I was talking about. You can have a single component and choose the right frequency and the channel that you want to with our single component.
Okay, so in other words, like today's mobile devices, including cell phones, they have multiple filters to deal with the multiple bands, which, it's like, I guess there's various different bands supporting, 2G, 3G, 4G. There's also different bands supporting different operators and different frequency bands around the world. We have the FCC in the U.S., but Europe has their own FCC and China has their own FCC. So you basically have all these different filters, and what you're talking about is increasing the performance of the existing type of solution and then ultimately replacing it with something that's tunable versus single band.
Absolutely.
Okay.
Yes, yeah. You said it best. Basically, we are. I think ultimately, what is going to be the value for the consumers from this perspective is, for instance, they're looking at unlocked phones. What does an unlocked phone mean? You want to be able to switch your phone from Verizon to AT&T. And for that to happen, you need to have the bands that AT&T supports as well as Verizon supports.
Okay, cool. That's really interesting. Now, I mean, obviously filter companies have been around forever, longer than probably me and you have. all the way back to the RCA days. So, how is it that you're coming up with this unique idea now? Is there some breakthrough science that's occurred in the last 5 or 10 years, or you're just thinking about things in a different way, or what's the real innovation here? Because obviously this is a big deal.
No, absolutely, and it's both of the things that you said. Filters up to today, they have been designed based on textbook approaches that have been around for 50 years.
Okay.
And what we do, especially with the time we spent at USC at university, we actually broke a fundamental performance trade-off in filters. That trade-off doesn't exist anymore if our architecture is used.
Okay.
And it enables a 10 to 30 times performance enhancement in critical performance metrics of filters.
Okay.
So that's one of the things that we're adding. We are adding a magic dust that enables filters to improve or have better performance. The second factor behind it is we can be looked at as an agnostic technology or a complementary technology to existing filters.
Okay.
So you said it right. Filter manufacturers have been around for the past 50 years. There has been so much money invested in that sector in the industry. And we are going to leverage that. We are not going to revolutionize how filters have been manufactured. We will leverage the same manufacturing approaches, standard manufacturing approaches, but we will add our architectural innovation to add significant performance enhancement.
Okay, that makes sense. So this was technology that was developed with you and your co-founder at USC. So I'm assuming is it patented or trade secrets, or how do you protect the intellectual property?
So we are doing that at multiple layers as well. Obviously, it's a core technology. So originally we had 5 inventions, patents that were filed at USC, and we have continued the growth of our patent portfolio. We have a total of 12 patents pending right now, and we are in a so-called white space where our technology is very valuable, and it's a space where we can grow our portfolio very easily. The second aspect of this is, as I said, we are working very closely with standard manufacturers and partner up. Maybe in some cases work on some exclusive deals with some of these manufacturers that will enable us to be the sole provider of this technology. So there are multiple layers that we will be able to protect the technology and the product.
Okay. Now, how hard is it, as guys that work for USC, teaching, researching, all that kind of stuff, taking the technology out of academia into the commercial world? How does that work? I mean, I'm sure there's a lot of inventors out there. I mean, there's definitely been guys from Stanford and guys from Cal Berkeley and USC and Caltech that have done this. But for our viewers, how do you go about doing that? Do you approach the president of the university or the dean, and then how do you share the intellectual property?
That's an excellent question as well, and obviously we have gone through that process. So universities are realizing the value of their research that is being done, and even though they're nonprofit, they're actually realizing how to profit from the technology. Yeah. Now there are 2 tiers, and one tier is licensing the technology out to existing let's say big corporations who will take that, and it's easy for them to scale up and develop products out of the technology that was developed. Mm-hmm. This is a standard licensing model. More interestingly and more recently, universities are realizing the value of enabling startups based on the technology done by the founders who came out of the same university. And for us, the way it's happening is most universities have a standard arm for technology transfer. Mm-hmm. So you would go through the similar path of licensing the technology out. This is what we did. You negotiate as a company, you negotiated a license agreement with the university. Some universities are more generous than the others. Some universities have the policy of taking some equity in the company, and they just let the inventors run the company. And some are interested in also getting some royalty. The second aspect of this, which is important, and we are realizing this especially as a hardware component company, is taking the research out and making it into a product is a whole new world. So even though we have a hardware proof of concept product and we have shown that our concept works, making it a product is going to be, what the company is going to focus on. It's going to be a tough challenge.
Yeah. But I'll tell you, I've been involved with a lot of filter companies over the years, and, one of the things that, I'm not the hardcore scientist, I've been on the business side of engineering for so many years, but I have talked to some of the hardcore scientists that are investors in your company, and the fact that you actually do have measured data mm-hmm. is a huge deal. Mm-hmm. It's a big part of the proof of concept. So can you talk a little bit about that and why that's important?
Absolutely. So I think I didn't allude to this. In the few years that we spent time at USC, that was our focus. We could convince, especially a few research departments at the Department of Defense, that this is an important problem, and it's a hard problem mm-hmm. that we are trying to solve. So they supported us, they funded the research and development, and our goal was to show the concept, which was an architectural concept that we came up with, to show it and demonstrate it to them and later to potential commercial customers in hardware. And this came as a result of talking with multiple customers and realizing that they just don't believe in an idea. They want to mm-hmm. see that this concept is going to work. Of course. To be honest with you, it was not easy. I mean, they were right. Mm-hmm. We had to for us, we have a proof of concept, which is a PCB with multiple components on it. We had to go through multiple rounds, and we learned a lot during that process. Just what are the practical difficulties that we will have to deal with.
Okay.
So that you're right. You're absolutely right. We are seeing when we talk to people right now, to potential investors or potential partners and customers, that that hardware prototype proof of concept is actually very valuable.
Okay. So for those who don't know, a PCB is a printed circuit board. That's the board that you actually put chips onto.
Right.
So you've been able to show in this hardware kind of validation method that you do get this 10 to 30x performance improvement over conventional means?
Exactly, absolutely. In fact, what we've shown, and after we made the claim that we have this few commercial customers, big corporations that actually came and see it in our lab to make sure that we are, what we have is what we're saying we have, and that's exactly what we showed. We showed an unprecedented performance, with simple filters, with our architecture around it. We showed improvements up to 30 times better performance in a traditional filter.
That's awesome. So basically, it's hard science, it's hard engineering, it's proof of concept, big market opportunity, with broad commercial applications. But let's just talk about the initial market opportunity, the mobile device market. How big is that in terms of the market for filters and into mobile devices?
It's so RF filters is the fastest growing piece of RF market, not necessarily in mobile only, but driven by mobile. It's estimated to double in size every 2 to 3 years. And right now we're talking about, for the whole market for mobile devices only, we are talking about a $3 to $4 billion market size. And it's just increasing. And we are targeting the high end of that market, which is, again, in the segment is the fastest growing part, because most smartphones are going to need high-end filters as we move forward. So yeah, we're talking about multi-billion-dollar market size, which is really exciting for us.
Totally. Now, I think when we've talked previously, you talked about there's an infrastructure market, which I guess is like cell phone towers in addition to the mobile market. Mm-hmm. Can you talk a little bit about the applicability of the technology to the infrastructure market in addition to the mobile market?
Absolutely. So especially as we go to more advanced 4G and 5G, we are starting to talk about it. The infrastructure is going to be closer to a heterogeneous model where you have a lot of mobile devices. Everybody's going to have one. And then you're going to have these mobile devices needing to talk to a tower, traditionally a tower, and right now maybe to a smaller cell, which is in the mall area or in the coffee shop.
Okay.
And all of those devices, similar to mobile devices, they would need to have filters in them.
Okay.
They need to communicate at the same frequency bands with the some mobile devices. And we are seeing, as we talk with potential customers, that they're dealing with the same type of challenges too. And our technology definitely has applicability in that market. There's few customers that we are in conversations, with the specific product, which is, basically with minor modifications in our product definitions, we can address that market as well and create more revenue paths for us.
Okay, so the story has legs to it. There's multiple opportunities beyond just the initial mobile market, which is, I guess, most of the volume today is 4G in the U.S. Is there still any 3G out there? Or?
There's actually still 2G as well. It's been around for 30-something years, and it's rolling out.
Yeah.
3G definitely is one of the growth paths as well. There are many bands in 3G and 4G that they're shared. Okay. So, if you make a product, it can be applied to both 3G as well as 4G. Some parts of the world, they are developing 3G and 4G infrastructure and mobile devices in parallel.
Okay.
Because 3G still has its advantages. It's less expensive. Some emerging markets would prefer that. But 4G is definitely the dominant market for that.
And LTE kind of dominates the 4G market?
That's correct, yeah. Okay. And eventually LTE became equivalent to 4G. We had WiMAX originally in some parts of the world. It was deployed, but LTE seems to be the winning solution.
Okay. And then what stage are you at in terms of your product development?
We are an early stage company, so we have, as I said, we have shown a proof of concept hardware prototype. and we have a plan to develop our first MVP, or our minimum viable product that shows the advantage of the technology in terms of a real product that meets the specifications. And our plan is to develop our first product and alpha samples and beta samples over the next few quarters.
Okay, so not too far out then. You know,
Oh,
you're
absolutely.
kind of within a
Yeah.
1 year window, so you are early stage, but because of all the work you did at USC, you're pretty far along in terms of the proof of concept, and now it's just commercializing it, getting it in a commercializable form.
Exactly. We believe that a couple years that we spent at USC actually significantly reduced and de-risked both the technology and the time to development of it. So we
Okay.
are ready to get into market as soon as we have the
And
product.
what does the competitive landscape look like? You know, what's the incumbent, existing filter players, and what do they offer? And, are there other people doing what you guys are doing?
Um, Absolutely. It's, as I said, it's a really hot market. It's
Sure.
growing really fast. And consumer demands, they're never ending. So the incumbents, the big filter manufacturers, they're working on improving their own devices as well. There's a lot of investment in those, for instance, increasing capacity, in adding more manufacturing capability along the same traditional lines. So it's not that there's new innovation going on, but there is definitely investment.
So
Yeah.
there's incremental stuff going on with the
Absolutely.
incumbents, but you don't see anything that's breakthrough happening with the existing players.
Not at all. Even on the startups, we do see that a few startups coming out, again, working along traditional scale. So, for instance, can we have a better material that can incrementally improve performance?
Okay.
Or can we have a better circuit that can incrementally improve performance? So we do see investments in those areas, well, which in a sense actually resonates with our message, because we are complementary to all of that. We have architectural advantage that nobody else has, and we add significant improvement in performance.
Okay.
So we like the fact that the investor society as well as the industry itself is realizing the need for more investment in the filter area.
Okay. Now, in addition to, you're kind of focused on the performance element of it. Is there a cost benefit to using your technology? Because I mean, these mobile devices, they're getting so expensive, and it really prevents them from penetrating a bigger portion of the overall market. Breaking into different price points. Mm-hmm. So does your technology enable that?
Absolutely. So at the core, we enable performance, like significant improvement by improvement in performance by breaking a trade-off. However, when we have that performance at hand, depending on the segment of the market we want to address and add value to, we can actually trade that off. So for the mobile market specifically, our early products, they're going to enable an existing low-end technology that has a really well-known and small cost structure, or low cost structure, to compete with high-end filters, which are known to be really expensive. So suddenly, a lot of potential customers of us will be enabled to sell low-cost filters at high prices.
And so you're basically drawing a whole new price performance curve.
Exactly.
So it's not just that you're providing additional performance, you can enable different levels of performance at different cost points than previous solutions could.
Exactly.
Okay.
Exactly.
That's awesome. Let's see what else. Those are my main questions. Other than when are you going to be generating revenue? Do you see a clear path to profitability?
So with the current plan that we have, our product development, as you pointed out, is going to take a few quarters, and then we are looking at being able to capture market share with our very first products anywhere in 2018.
Okay.
Depending on the segments that we are addressing, we can have actually extremely high margins. So as a company, we are focusing on our core expertise, which is that core technology, developing our engineering team really well, and having the first product out. Our current financial projections actually show really high margins with the business plan that we have. And as a result, we will be really printing money by 2018, 2019.
So, this is a hardware company. This is hard science. This is difficult engineering. These are long development cycles, long sales cycles, similar to my old company, Entropic. So, and you've got basically a multi-year process here between developing the product, getting it designed into OEMs, original equipment manufacturers, and then ultimately getting it deployed with the big carriers, the big operators like a Verizon or an AT&T. So how do you keep investors interested? How do you get the interest of investors? How do you keep them interested and keep them patient through a process that's going to be a multi-year process before you get to kind of the 2018, 2019, where you start, getting bigger revenue and ultimately profitability?
Oh no, absolutely. I mean, you're right. It's a hardware company, and with it comes longer development times. For us, the big prize obviously is there. It's clear that it's a huge market,
Yeah.
and if we can gain enough momentum and capture some of that market, it's going to be a big prize. However, in the meantime, as a hardware company, we will be having multiple milestones that will show progress towards getting to that big prize.
Okay.
And this is how we've actually operated so far. We have worked on our proof of concept prototype just to show the concept works. Our next step is developing our MVP. We are going to show tractions from customers as we have our alpha samples, and multiple milestones on the way is going to keep investors calm and happy to show that we are actually getting close to that huge prize.
Okay, awesome. And kind of along those lines, have you have a pretty good idea about how much money you need to raise overall? I mean, not saying initially, but kind of before you get to profitability. I mean, is this like $5 million, $10 million, $50 million, $100 million? I mean, just ballpark it for me. What are investors looking at before you get to kind of ultimately generating the big revenue and the profitability?
Absolutely. So one of the things that maybe I should have made clear from the day one is that we are not a SoC or a complex semiconductor company, similar to what Entropic was.
Yeah, Entropic had 80 million raised
Right.
before we got our first big deployment.
Absolutely. So we are nowhere close to that.
Okay.
Even though we are still developing hardware samples and so forth. So we are looking at about in the ballpark of $10 million maybe to get to a place where we have proven profitability.
Okay.
And obviously we're going to raise that in multiple rounds,
Sure.
again, to show that we do have the traction, we do have the product developed, and there's interest from the market, and then we will use a second round for the growth.
Okay, awesome. And then what's your exit strategy ultimately? How do investors get their money back? And hopefully a huge return.
Yeah, well, absolutely. Well, we think that there will be huge return because there is a pressing need and a huge prize. As a business, we are focused on revenue generation, profit generation,
Yeah.
and creating more and more revenue path. But obviously, we are not naive. We understand that, especially in the industry that we are, it's a more traditional, consolidated industry. Big players are more interested to have the technology companies for themselves, block others from having their hands on, and actually bring in the margins in-house.
Yeah.
And as a company, we are focused on our core expertise. We are building our team, we are building our IP portfolio, and we want to get to a point that we will show traction, commercial traction of this technology. And I don't think it's unpredictable, or it's foreseeable that with many players out there with interest in this technology and in this market, that we get acquired at some point.
Yeah.
And if it is the right price, we are not against that.
Sure.
And I'm sure our shareholders, our investors are going to be happy about it.
Yeah, makes a lot of sense. Well, I mean that's pretty much all the questions I had. Did I leave anything out that you want to talk about yourself or ABtum or anything like that?
No, I think we pretty much covered everything. So I appreciate you having me, and I hope that your audience are going to enjoy this conversation.
Thank you, Behnam. I really appreciate it. So this is Patrick Henry from QuestFusion with The Real Deal What Matters.